Hi, this is Dave Johnson with another edition of Math Off Topics. Today I want to show how to derive the factorial property of the gamma function. And that property can be used in important ways, which we'll see in another video. So let's get into it. So here I've written the definition of the gamma function, gamma of x, and so x is the independent variable, is equal to it's an improper integral from 0 to infinity of t to the x minus 1 e to the negative t dt. I want to point out again, so x is our independent variable of the function gamma, but it appears, let's say, as a parameter in this integral. The variable of integration is t. So to demonstrate the property, what I want to do is I want to start with gamma of x plus 1 and just substitute. We get the integral from 0 to infinity of t raised to the, now x plus 1 plugged into x will give you, so subtract 1, you get x here, times e to the negative t dt. We're going to evaluate this using the integration by parts. This is a method that you hopefully learned in Calculus 2 or you've seen it someplace. I'm not going to talk much about it except to say that we break the integral into parts and we, let's say, if we do that properly, we can write this as u v evaluated from 0 to infinity minus the integral of v du, again evaluated from 0 to infinity, where u and v are chosen appropriately. I like to choose my u so that it's easy to differentiate and my v so that it's easy to integrate. So let's say u is equal to t to the x and dv is equal to e to the negative t dt. And if we evaluate v, so integrating, we get negative e to the negative t. And if we differentiate the u, now we're differentiating with respect to t, and so this is a power function. So du is equal to x t to the x minus 1 dt. And now we can plug in, so gamma of x plus 1 is equal to uv, so t raised to the x times negative e to the negative t, and that all evaluated between 0 and infinity, minus the integral from 0 to infinity of v du, so negative e to the negative t, that was v, and then the du is x t to the x minus 1 dt. Okay, now I want to just mention, I'm not going to spend a lot of time on this, but if you plug in the infinity here, you'll get, it's technically a polynomial for a fixed x, or power function for a fixed x. And the negative sign isn't going to matter here. And then the e to the negative infinity is 0. And now that's a common limit that you probably did in Calculus 1. And that limit is going to be 0. If you plug in 0 here, 0 raised to any power is 0, as long as x is not 0. And then this is going to be e to the 0, which is 1. And so you get 0 times 1, which is 0. So I can write this result as 0. And then the negative signs in this integral cancel. So let me say plus the integral from 0 to infinity of e to the negative t times x times t to the x minus 1 dt. But I want to rewrite that in a more familiar form. I won't write the 0. Also, I'm going to pull out this x. Now, how can I do that? Well, x is a constant with respect to this integration. And we can think of x as a fixed number. T is the variable of integration. So I'm just going to factor that out of the integral. And so we get x times the integral from 0 to infinity. I'm going to rewrite this, put the t to the x minus 1 in front, and then e to the negative t dt. Well, this is just what we started with for our definition of the gamma function, gamma of x. So let me write that. Notice here, integral from 0 to infinity, t to the negative t to the x minus 1 times e to the negative t dt. That's exactly what we have here. So I can write this as gamma, gamma of x plus 1 is equal to that x that's out in front times gamma of x. Now I want to go one step further and say, and by the way, this is the property that people cite when they talk about the factorial property of the gamma function. However, let's make this a little clearer. And so if we let x be an integer, and let's call it n, now can we do that legally? Well, sure, because x is just some real number. And so if we let x be an integer, and we'll call it n, and we can, let's confine ourselves to non-negative integers, 0, 1, 2, 3, and so on, then I can rewrite this as gamma of n plus 1 is equal to n times gamma of n. Okay. But gamma of n plus 1 is, if you think about what's going on here, if this is going to be any sort of factorial property, this is going to have to be n factorial, because then that would be n times n minus 1 factorial. Okay. So that's what we're looking for. But what does that imply? Well, if you plug in n plus 1 in for x right there, what we get is that n factorial is equal to the integral from 0 to infinity of t to the n e to the negative t dt. And that's actually the useful property that we're going to use later on in another video to do interesting things. So, and I also want to mention that if you plug in n equals 0, you're going to get t to the 0 here. But that's okay. T to the 0 is 1. And the integral from 0 to infinity of e to the negative t dt does turn out to be 1. So everything's cool. So that's our result. I hope you've enjoyed this video. If so, please like and subscribe, and I'll see you in the next video.